When I get up in the morning, one of the first things I do is make coffee. My day just isn't right without it, and the sooner I get it into my system, the better. Then I usually make some scrambled eggs with a bunch of veggies and cheese, and once that's eaten, I am ready to take on the day. I don't know what I would do without mixtures, because these are what start my day off right. A mixture is a combination of two or more substances that each retain their own properties. My black coffee is a mixture of water, caffeine, and flavor, and my breakfast is a mixture of eggs, cheese, and chopped veggies. Mixtures aren't just limited to your morning routine, they're common everywhere. The atmosphere is a mixture of different gases, and the water that comes out of your tap is a mixture of water and other dissolved components like calcium and chlorine. Mixtures come from physically combining elements and compounds. An element is a material that is made of only one atom, and elements chemically combine to form a compound, which is a group of two or more different atoms chemically bonded together. But as you can see, even though coffee and scrambled eggs are both mixtures, they're not the same. Each is a different type of mixture. The eggs are a heterogeneous mixture because the different parts of the mixture can be identified as individual substances. I can easily see and identify the different components of the scramble, hetero means different, like the onions, peppers, and cheese. In contrast, my coffee is a homogeneous mixture because it has the same composition throughout, and homo means same. You can't see the caffeine and flavor molecules mixed into the water, but I guarantee they're in there. When all components of a homogeneous mixture are in the same phase, we have a solution. The air we breathe is a solution because all of the different components are in a gaseous phase. Same with a glass of salt water. The sodium and chlorine are dissolved in the water, and all components are in a liquid phase. Solutions can also be solids. Gemstones are solutions of different elements and compounds, but the different components are indistinguishable within that homogeneous solid mixture. An important thing to note about solutions is that just because all components are in the same phase doesn't mean they're all present in the same amount. If there is one component that is present more than any of the others, we call it the solvent. Quite often in a liquid solution, the solvent is water, which makes it an aqueous solution. Both your tap water and the glass of salt water are aqueous solutions because water is the component present in the greatest amount. Any other components in the solution that aren't the solvent are solutes. The chlorine, fluoride, and calcium in your tap water are solutes, as is the salt in that glass of salt water. We call the process of mixing solutes with solvents to form solutions dissolving. Once those solutes dissolve completely into a solvent, a homogeneous mixture is formed and we get our solution. Salt and sugar dissolve pretty easily in water. It takes just a few minutes of stirring before your solution is completely mixed. But not all solutes mix so quickly. The ability of a solute to dissolve in a solvent is called its solubility. The solubility of a solute depends on the attractions between the particles of the solvent and solute, as well as the attractions between the solute molecules themselves. If a solute dissolves quickly and easily into a solvent, then the solute is soluble in that solvent. Notice how much the word soluble sounds like solute? If the solute doesn't dissolve well, then we say it is insoluble in that solvent. We say in that solvent because the solubility of a solute depends on what you are trying to dissolve it into. And not all solvents dissolve different solutes the same either. It's all about those interactions. For example, water is very good at dissolving sugar molecules, but not so good at dissolving oxygen molecules. The sugar molecules are pulled away from each other much more easily than oxygen molecules, making sugar quite soluble in water and oxygen quite insoluble in the same solvent. While some solutes may easily dissolve in a solvent, there's a limit to how much solute can go into any given solution. If you try to dissolve sugar in a glass of water, you would be able to do so only to a certain point, after which the sugar would just collect on the bottom of the glass. Once you've gotten to the point where no more solute can be dissolved in the solvent, you have a saturated solution. You have quite literally saturated the solution with solute. Up until this point, though, you can say that you have an unsaturated solution because more solute can still be dissolved by the solvent. I mentioned solid solutions before, but there's a special kind that deserves a little more attention. This type of homogeneous mixture, called an alloy, is a solid solution of different metallic elements. Brass is an alloy because it's a homogeneous mixture of copper and zinc. Stainless steel is a solid solution of iron, chromium, nickel, and carbon, so it's also an alloy. Yet another alloy is white gold because this is a combination of yellow gold and a white metal such as nickel or platinum. An amalgam is a type of alloy that you may be familiar with if you've ever had a filling put in your tooth. This is a solution of mercury and another metallic element, such as silver. Mercury is liquid at room temperature, and when initially mixed with silver, it creates a very soft but solid solution. The amalgam is put into the cavity in your tooth, and after a while, the mercury works its way out of the solution, leaving the silver behind as a solid filling. Mercury is quite dangerous, though, so many dentists have stopped using amalgam fillings in order to avoid the risk of mercury leaching from the filling and into your mouth. Before this lesson, you may have thought that mixtures were just simple combinations of materials. By now, you should see how many different kinds of mixtures there are and what makes each type unique. When the different parts of a mixture can be identified as individual substances, the mixture is heterogeneous because hetero means different. If, however, the mixture has the same composition throughout, then it's homogeneous because homo means same. If, like air and water, all the components of a homogeneous mixture are in the same phase, that mixture is called a solution. Solutions can be solid like alloys, liquid like an aqueous solution, or gaseous like our atmosphere. No matter the type of solution, the component that is present more than any of the others is the solvent, while any other components in the solution are solutes. Solutes are mixed with solvents by dissolving, and the ability of a solute to dissolve in a solvent is its solubility. Solutes that dissolve significantly into a solvent are said to be soluble, but if the solute doesn't dissolve well, then we say it's insoluble in that solvent. Even if a solute is soluble in a solution, there is a threshold for how much solute you can dissolve. If you reach the point where no more solute can be dissolved, then you have saturated the solution. Up until that point, though, your solution is unsaturated because more solute can still be dissolved by the solvent in your mixture.